Alright, welcome. In this video, we're going to look at vectors. What are vectors? What can we do with vectors? And so on. So, to start with, what is a vector? Well, for the purposes of game development, here's a simple definition. A vector is a mathematical structure which holds any number of elements. This is a two-dimensional vector. This is a three-dimensional vector. We can have 4 dimensions. We can have 1 dimension. We can have as many things as we want. 2 and 3 dimensions are the most common. Now, I can hear my professors screaming at me already, knocking my door down, saying, hey, you can't use a working definition because this is not actually the full rigorous definition of a vector, but in a few videos I'll actually visit the formal definition of a vector. But anyway, so there are 2 things that we can use to represent with this. Oh, first of all, we can represent any arbitrary information that we want. These elements are just numbers, and so we can put any numbers in there, and that represents data of some sort. But geometrically, it's common to interpret these vectors as either points or directions. So if I take the vector, which is 1, 2, then I can interpret that as, if I go in the x and the y, and I go 1 step along in the x, 2 steps along in the y, that is my point. It's also common to put this little tilde underneath the letter to signify that it's a vector. Okay, so that's one use, is to describe a position. Another use is to describe a direction. So if I say, okay, 1, -1, another use for that number is to say it's the direction which goes 1 in the horizontal and -1 in the vertical. So we can actually start this from anywhere. It doesn't matter at all. Why not? And we'll go 1 in the horizontal and -1 in the vertical, and so that is that vector. Side note, we can actually, it doesn't matter whether we consider these points or directions, because a point is like a direction from the origin. If I'm at the origin and I go 1 across and 2 up, it's the same thing. So don't let yourself get too panicked about that sort of stuff. In high school, a lot of classes will act like the highest level of intellectual achievement someone can make is plotting a vector in 3D. Okay, that's an opinion, I guess. But let's go ahead and do that. Let's plot a vector in 3D. So we could put in any numbers we want. I'm just going to keep it simple. We're just going to go 1, 2, 3. I am very imaginative. 1, 2, 3. Okay. So I would view this as a step of 1 in the x, and then followed by a step of 2 in the y. 1, 2. And then followed by a step of 3 in the z. 1, 2, 3, possibly not to scale. And then where that ends up, that is the vector. If this is a point, yep, there it is. If it's a direction, we might also want to draw the arrow to indicate the direction. Okay, so operations we can do with vectors. We can add them together. In the case of v plus u, that's 1 in the x, 2 in the y, plus 1 in the x, minus 1 in the y. That comes out to add the horizontal steps together, add the vertical steps together. That is 2, 1 as our resultant. Okay, another way we can visualize this is graphically by drawing it. So we can say, okay, 1, 2, there we are. There's our v. 1, -1, So we go 1 across, -1 there. That's our u. And then from the tail up to the head, is it tail to head or head to tail? Point is, we follow the progression of motion, and this is v plus u over here. We can also subtract vectors. For any vectors, v plus, oops, gave myself away. It's not plus, it's minus. V minus u is really just the same thing as v plus negative u. And what we can do is we can say, okay, say I have a scalar, so just a regular number, and I multiply it with a vector. Well, then this is multiply it component-wise into the vector. I'm just doing two-dimensional because it's less writing. Exactly the same happens in 3 dimensions. And then geometrically, we can say, okay, well, if we have some vector, wherever, there's our v, and we multiply it with a number, then what that does is it squashes or stretches the vector along the same direction, because we're taking that fundamental direction and lengthening it or reducing it. Or if a is a negative number, we could even be flipping around, but still in the same line, in the same direction. So this all looks very coherent. Wonder if there's anything I missed. Anyway, let's go in and look at an implementation of this. So here we are in Visual Studio Code. I'll be doing these examples in Python. In Python, vectors are represented as NumPy arrays. So let's go ahead and import that. Okay. Now what we can do is we can define a vector v. And we do this by constructing a NumPy array. We put in a list, so I think it was 1, 2 was the v I was working with here. And it doesn't matter for this example, but I'm going to keep this consistent. For OpenGL, they need to be 32-bit floating point numbers. By default, there'll be 64-bit floating point numbers, and it needs to be this way for OpenGL to read the data properly. Okay, so what I'll do is I'll just print v. Okay, give that a go. Yep, we have 1, 2. That looks good. However, nah, it's fine. We'll work with this. What we should really be doing is really each of these. It should be defined as a so each entry, vertically, like I was drawing before, and this will pretty much. Oh, out of range. Of course. What am I thinking? Okay, this series is off to a good start. So here we've defined it, and we can see our vector there. That looks great. Okay, so we've got v. Let's make u, and we'll go through the example of adding vectors, subtracting vectors, and multiplying vectors. Okay, so u, I think I had 1, -1. Okay, so the first example I did was adding those together. So we'll go print that, u plus v. Let me try that again. We go w. I'll go v plus u. It doesn't matter. It doesn't matter which order I do that. Oh, what am I thinking? That was correct. Okay, yeah. I've just zoned out for a second. So yeah, let's check this. V plus u, element-wise. 1 plus 1 is 2. 2 plus -1 is +1. Okay, awesome. So, yep, that is working. Then the next thing I want to do is subtract. So now I'll say, okay, now w equals v minus u. And let's double check this before we do it. So 1 minus 1 should be 0. So we should have 0 as the first element. And then 2 minus negative 1 is 2 plus 1. So we should have 3 as the second element. So we'll do this and then we'll print it out. Yep, that looks great. And then last example, w equals negative 3.5 times v. Okay. Oh yeah, of course we have to print it, don't we? Okay, so again, before I do this, I'll check it. Okay, so negative 3.5 times 1 should be negative 3.5. 3.5 times 2 is 7, so I should have negative 7 as a second component. And yes, that looks great. Okay, so anyway, this has just been a little quick introduction to what vectors are and some basic operations that we can do with vectors.